So here we have a second generation time machine ball clock mechanism. So there are basically three parts to it. This is quartz clock that has a switch, and every time the switch goes on it activates the motor, and then there is another switch here that stops the motor when it does the full rotation. So there is a switch underneath this dial that activates the system, that activates the circuit, and another switch here that stops after the clock does the full rotation, the arm does the full rotation. As you can see, there is a very simple DC motor here with 3 gears, and this is the spindle that the arm picking up balls sits on. And here is the circuit, electronic circuit, a small PCB that controls motor and takes the impulse from this switch and from this switch. Currently it is running off 5 volts, so it is perfectly acceptable to power it from the USB power supply, USB socket. It's in a full working order, so I'm actually going to put it back. PCB contains a very simple circuit that basically delivers power to the quartz clock and to the motor. So there are 2 parts to the to these components on PCB. 2 transistors provide stable voltage to the clock. So the positive terminal, either from the battery compartment or the input positive pin from the socket at the back of the clock, goes through the diode. I think it is a simple 4001. So the voltage drops here by about 0.7 volts, and then it goes through this NPN transistor into the clock. So the transistor is stabilized by this circuit here at the base. So it basically controls the output voltage and either opens or closes this this transistor, and then there is a capacitor to smooth all the voltage going into the clock. So there's drop of 0.7 plus drop on the this transistor, and then obviously there is some feedback here at the base of the of this NPN that provides voltage to the clock. I haven't measured the resistors, I haven't measured the output voltage, so I am unable to tell you what exactly the output voltage measured in the circuit. But there's hardly anything that can go wrong. This transistor, if the voltage is too high, or there is any short in the circuit, probably these transistors are going to fail. So these 2 transistors plus the 3 capacitors and 3 resistors and 1 capacitor provides voltage to the clock, to the quartz clock. And then the second part is the voltage control to the motor itself. It's very similar arrangement. As you can see, two transistors with feedback here at the base, providing stable voltage to the motor, again with some smoothing capacitor, 100 mics at the output. Now, how does there are two switches. One is at the quartz clock, at the spindle of the quartz clock, and the other is at the spindle of the arm, rotating arm. And depending on the positions of these switches, the clock, the arm action, the motor is activated, runs and stops. One of the switches is normally open and the other is normally closed. So normally open switch is at the clock, normally closed switch is at the gears. And what happens when the clock does not run, so when it does the full rotation, both switches are open. Okay, then the quartz clock, when it goes to 0 seconds, closes the switch at the clock spindle, and that triggers the transistor, so the current is going into the motor. Because there is enough of time for the gear switch to close before this clock switch opens, it does the full rotation with the gear switch closed, but as I mentioned, clock switch opens soon after it starts rotating, and it does the full rotation, and then the switch at the spindle and the arm spindle opens, and we need to wait again for the trigger to happen at the clock spindle. And that's basically what these two switches do. So if the clock does not rotate, the first thing to do is to check the switches, whether the gears engage and close them properly at the quartz clock and at the spindle. And then obviously we need to check the transistors, whether they are all right. That's more or less what can go wrong. And that's how the circuit, that's how this PCB works. There is really nothing too complex about that, and hardly anything can go wrong with this circuit.